right. So as usual, when it comes to the test, I'm not going to go over it simply because everybody's question numbers are different. And so your number 5 is going to look very similar to somebody else's number 5, but it's going to have a different set of values in it, okay? So I did leave you some messages on the test itself, so you can go back and review the test and take a look, try to figure out what you did wrong, learn from your mistakes. Let me say this. I've been reading a book. I started it this past weekend. And when I say reading, I'm doing it audibly because I don't have time to pick up a paper book and read. So I can read while I'm driving if I'm listening to it. So I've been reading a book since this past weekend. And one of the things that keeps coming back over and over and over and over and over and over and over again. And it's something that I've been saying in my classes for a while, but this is an actual psychologist perspective. So there's scientific reasoning that backs this up. It's not just the old math teacher who keeps saying it. And that is the following. When you are getting when you're getting answers right, when you are when school is easy, when you're not having to work very hard, quite frankly, you're not learning. Your brain is not growing. When you are making mistakes, when you are struggling, when school is hard and you're pushing through, that's when your brain is actually physically growing. It is changing. So I know that for some of you, you would be like, I just wish we could do the easy stuff all the time. You know, like, let me just type into the calculator sine of 47 degrees over and over and over again, and I'll get it right every time. And that would be so nice because it would be easy and you're not going to learn a thing. Your brain's not going to grow at all. It's the act of making mistakes and learning from those mistakes that causes your brain to grow. So when my students make mistakes, I get excited. Not because I'm sadistic, not because I'm a mean witch of a teacher. Okay, that's not why I get excited when my students are making mistakes. I get excited because that's when they're learning. That's when their brain is growing. That excites me. So, so take the opportunity to learn from the mistakes on your test. And for the record, everybody made a mistake somewhere. Okay, there are several of you who got over 100, but only because of the extra credit I gave you, not because you didn't miss anything. Nobody got 100 just because they didn't miss anything, okay? So everybody made a mistake on the test, everybody. And so go learn from your mistakes, not right this minute because we have other stuff to do, but learn from your mistakes. Remember that chapters 9, 10, 11, it's basically one big chapter, okay? So everything that we learned for this test, we're using on the next test. We're gonna continue to use that stuff. So if there's something that you're feeling a little uncomfortable about, make sure to get a good grasp of it because we'll probably use it again, all right? So that's very, very, very important. As always, if you've got a question on your test, you're looking at a question and you're reviewing it and you're like, I still don't know what I did wrong, or I still don't know how to work this out, contact me. You've got multiple ways of contacting me. You can text me, you can email me, you can drop by my office during my office hours. I have no problems with any of those things, okay? So please, if there's a question on your test, ask. Don't let that be an unanswered question. Ask me about it. I did get an email, thank you Cecilia for pointing this out. Some of my lab grades have waxed themselves out. Let me explain what's happened. This keeps happening and I don't know why it keeps happening. But every couple of days, my lab will take grades that I have omitted, like the practice test or the learn section or the practice what you learn, and it omits it and puts a grade in for it. And I haven't figured out why or what's going wrong. So occasionally I'm checking it, but understand this is not something I'm checking on a daily basis, okay? I know your grade is important. I promise. When I go to submit your grades at the end of the semester, I'm gonna make really sure that every single thing that's supposed to be omitted is omitted and everything that's supposed to be graded is graded. In the meantime, I will check it occasionally. Feel free to text me or email me and say, hey, Ms. Roberts, our grades are messed up again. It's gonna happen again, okay? It's happened about, I would say 4 times already this semester that I've gone in, I have fixed it and then it unfixes. And I don't know what the issue is, okay? So I promise you, when I turn in grades, they will be right. In the meantime, I will fix them occasionally, but I am not checking it every single day, okay? So just be aware that that is occurring. I think that's all I wanted to say. Do you guys have any questions for me before I get into section 9.4? Anything? Okay, then let's just go ahead and start. So 9.4 is today. We got fall break next week. I don't know about you guys, but I am more ready for fall break than I think I have ever been for fall break. Like this semester, I think is gonna kill me. I have decided I'm going away because if I stay here, I'm gonna work. So I'm going away. So I'm out of here for fall break. I hope you guys enjoy your fall break too. 9.4 is what we're gonna do today. 9.6 will be before fall break. 9.7 will be after fall break. I hate that I'm splitting those up. That's how the break came. So, and then we'll also do 10.1. Can I just say a little bit about these 4 sections? Okay, I know your test is a ways off, but I like to kind of give you a heads up as to what you're headed into. 9.4 is all about applications. Okay, so 9.4 is applications. 9.6 and 7 are both graphing sections. And you will be graphing by hands, okay? You will be graphing by hands. 10.1, did you guys take a geometry class? How does that work for you guys? Did you take geometry? Did you have to do proofs? 10.1 is proofs. Oh, it's okay, don't worry. I will walk you through it. Remember, struggle is where your brain's growing, Dylan. So this is a time that we're gonna get excited about struggling through proofs. Okay, because your brain will be growing, all right? No, yeah, okay, but he still doesn't believe me. But so the reason I have these 4 sections on their own test, I would probably consider, especially 9.6, 7, and 10.1, I would consider those probably the most challenging sections of the semester, okay? Not impossible, just challenging. I have placed on my lab, you better check at some point and let me know if I didn't. I have placed on my lab a copy of the paper textbook for 9.6, 9.7, and 10.1, the homework sections. Okay, listen to me carefully. I haven't quite decided how I'm going to do the next test, but the next test might be part paper and part digital, okay? That's kind of what my brain is going towards. I'll decide when I'm away for fall break. The paper part, you need to be practicing from paper to take a paper test well, okay? So what I've done in my lab, if you'll go under sections 9.6, 9.7, and 10.1, you're gonna see the homework sections there. And it's actually as though you had the paper book. I know you have this paper book, but it's a different book. You have the paper book. And then what I've done is I've circled the homework questions and I've worked them out for you, okay? You're also going to have my lab digital homework. You need to practice both. You need to practice from paper and you also need to practice digitally. In the graphing sections, my lab sometimes offers you a multiple choice graphing. And I'm like, seriously, eeny, meeny, miny, moe? I want you to graph by hand from scratch. without having the extra help of looking at 4 choices. Okay, so that's why I'm doing what I'm doing. A multiple choice proof is actually brutal. It's almost like you have to read through 4 paragraphs to figure out which one's right. I would rather you just prove it to me yourself. Okay, so you will have a paper portion. I just haven't decided if it's going to be all paper or part paper, part digital. Okay, so please, please, please practice on paper. You've got the homework there in my lab. And again, if you can't find it, text me. I'm 99% sure I put it there. Okay, but I'm second guessing myself. So if it's not there, please, please let me know. All right, now, did that spur on any questions? And no, I'm not grading your paper homework. I gave you the answers already. Okay, it's right there in my lab. So I'm not gonna grade it if I've already handed you the answers to it. Okay, I'm not grading you on what I can do. Okay, okay, enough of that. All right, so then let's head into 9.4. All right, so first of all, the directions here, solve the right triangle. You need to understand what that means, okay? Because normally in algebra, we solve for a variable, right? We've never had to solve a triangle. And what that means is that just go find everything that you're missing. If it says solve the triangle, find every single thing that's missing, okay? So when I look at number 1, and it says solve the triangle, can you first tell me, can I just ask a vomit question? You know, one of the easy ones. What are the letters for the sides of my triangle? What are the letters? Like, what's this side called? It's not X. If it's on the coordinate plane, it would be X, but this isn't on the coordinate plane. Say it again. No. B? Anybody want to see? Or anything else? Why is it B? It's opposite angle B. Okay, that's a really important concept there. Okay, so it's opposite angle B. Now, I did go through this. I think it was in section 9.2, 3, one of those. But it's been a little bit, and we haven't really used it that much. Okay, so the name of the side is always the lowercase letter that is the same as the angle opposite. The name of the side is always the lowercase letter that is the same as the capital angle opposite. So this guy has to be side B. What is this side right here called? Side A. And then what is the hypotenuse called? Side C. That's where the Pythagorean theorem comes in, you know, a squared plus b squared equals c squared. That's where that comes in, okay? Although I never use that because you might not have an A, B, and a C. Okay, so then what's missing? Angle B, okay? What else is missing? Side C, side B. All right, so first of all, you got to figure out what's missing. Now let's go find what's missing. Of those 3 things that are missing, what's the easiest to find? Totally angle B. And how am I going to get that angle? Yeah, so 90 minus angle A. Remember that in a right triangle, the 2 acutes are always complements, okay? You could have also done 180 minus angle A, and that would leave you with angle B. All right, so what is angle B then? Are you thinking? Are we doing anything? Is the brain moving? What you got there? 59.60. Okay, so Dylan says 59. What do you mean by 59.60? 3 59.60 degrees or 59 degrees, 60 minutes? Is it 59.6 degrees? Is that what you're saying? Okay. So if my first angle is given in degrees and minutes, my second angle should also be in degrees and minutes. All right, what'd you guys get for angle B? Hey, make a mistake. Let your brain grow. Or get it right. I don't care. I got some mutterings. I just don't have anything that's that I can understand. Come on, guys. I'm giving you something easy. All right, Savannah, what'd you get? I'm just going to start calling on people if you're not going to answer me.
48 degrees, 20 minutes.
48? How'd you get that?
180 minus the...
3140?
Yeah. Oh, is that 31? Never mind. I
Oh.
thought it was 131, sorry.
Oh, it's okay. Now, wait a second, Savannah. Does it make sense? 131 degrees? Okay, so think through that. Think through that. Go ahead, Yamin. 59 degrees, 20 minutes? 58 degrees, 20 minutes? Ooh, which one is it? It's 58. Did you put it in your calculator, Yamin? Or did you do it in your head? 90 minus 31. Yes, it is 90 minus 31, which is 59. But then you have to subtract even more from the 59, which takes you down to the 58. $90 minus 31 is 59. I agree with you. Okay, so you're sitting at 59 degrees. And now at 59 degrees, you still have to take away another 40 minutes. If you're at 59 degrees and have to take away 40 minutes, you're not still at 59 degrees. Now you're at 58 degrees. Think of it this way. If you're at 59 hours and take away 40 minutes, now you're at 58 hours, right? And 20 minutes. Same concept, okay? All right, now we still have to find side B and side C. For right triangles, we can use SOHCAHTOA, okay? I can't rely on things like X's and Y's and R's because it's not on the coordinate plane like it was in the last couple sections, all right? But I can rely on SOHCAHTOA. So let's go find side B first, simply because I feel like it. That's the best reason I got. So in order to find side B, what are some ways, thinking through SOHCAHTOA, what are some ways that I could find side B? Okay, sine of what? Angle B, very good. Since we know angle B, that would be good to use, right? Oh, but have you guys ever made a mistake in like adding and subtracting before? Yeah? Yeah, I mean, can I put you on the spot for a second? Because your brain totally just grew for a second there, right? There was a light bulb, I saw it. If I hadn't stopped you, and if you had used angle B to get side B, your original angle B, what would have happened? What's that? I just couldn't hear you. So if you had used the wrong angle B to find your side B, would your answer for side B have been correct? No, it wouldn't, because you were using something wrong to begin with, right? Okay, so here's my suggestion, guys. Try to only use your givens. All right, it's obvious that angle A is 31 degrees, 40 minutes. I didn't do anything to find that. So if you can use angle A, use angle A. If you messed up finding angle B, you're gonna mess up finding side B, okay? So was it you, Savannah, that said use sine? I agree with you, that's correct. But is there a safer something to use focusing on angle A? Tangent? Okay, so the tangent of angle A, by the way, could I use the cosine? What would cosine of angle A be? How many unknowns is that? So that wouldn't help me out too much, would it? Okay, so let's use tangent. Let's use tangent, all right? So tangent of angle A, we know is opposite over adjacent, so that's gonna be side A over side B. That's just using the letters. Let's go plug in the numbers. So the tangent of 31 degrees, 40 minutes is going to equal side A, which is 35 9/10, divided by side B. Okay, what's the math that you do to get side B alone? Sycuria? How are you going to solve for B? Good, multiply by 1 over 35.9. That is an option now. Sycuria, I got a question for you. When I multiply by 1 over 35.9, don't write this down, folks, because I'm going to show a different way. When I multiply Sycuria by 1 over 35.9, what's going to be left on this side? Good. Very, very good. 1 over B is going to be left, okay? Now, I'm not going to do Sycuria's method, but what she told me is totally legal and totally mathematically correct. What's another method of getting B alone? Because it's kind of a pain when it's down in the denominator. Yeah, I could multiply by B, and at the same time that I'm multiplying by B, what else could I do? Because that's going to give me a B tangent 3140. Yeah, divide by the tangent. All right, so that's going to be B is equal to 35.9 divided by tangent of 31 degrees, 40 minutes. Now, if you don't understand what I did, go ahead and multiply B first, and then do a second line where you divide by the tangent. All right, you got your calculators? Let's type this into the calculator. Type it in exactly the way you see it. Don't change it. All right, you got something for me? What do you have? Jaden? Are you in degree mode? Oh dear. Priscilla, what'd you get? Okay, so what am I going to write down, Priscilla? Very good. 58.2028. Did that fix it, Jaden, when you switched over to degrees? Man, that pesky mode, it just keeps messing things up, doesn't it? Okay, what else are we missing? And side C. So we now have this as our known. This is now known. The last thing that we need to find is our side C. So I can think of a couple of options for finding side C. What are some options? Okay, I could use the Pythagorean theorem. Can anybody tell me what a danger could be to using the Pythagorean theorem? Yeah, if your side B is wrong, then automatically Pythagorean theorem is going to give you the wrong side C. Okay, so do you see the domino effect here? Like if your angle B was wrong, it causes your side B to be wrong. And then if you use the Pythagorean theorem with side B, it's going to cause your side C to be wrong. So is there a safer method that you could use to find side C? Sine of angle A, and sine of angle A is going to give you what? Or what are you going to be using? Yeah, you're going to be using the opposite and the hypotenuse, and everything in that is given, isn't it? Yep, so that's safe to use because everything's been given. All right, so sine of angle A is going to be side A over side C. My angle A is 31 degrees, 40 minutes. My side A is 35.9 divided by my side C. Hey, doesn't this look a whole lot like working with side B? So let's multiply by C, divide by sine. And to save yourself some strokes in the calculator, all you need to do is second enter and arrow over to sine and change it into, arrow over to tangent and change it into sine. And you don't have to retype everything. Madison, what'd you get on that one? Agreed. Now, if this were a story problem, it isn't. But if this were a story problem, I am kind of a big stickler on providing labels. So if this had been a story problem, what kind of, now angle B already has labels. It's got the degrees and the minutes, okay? What labels would I have used for side B and side C? Kilometers, if it were a story problem. If it's not a story problem, I don't really care as much. But if it's something real world, I care, okay? All right, I'm gonna skip number 2 because it's very similar to number 4 and it's already worked out. Do I have it worked out on your notes or is it blank? It's worked out. Apparently I'm skipping number 3 as well. Let's go down to number 4. All right, so the first, let's just read through the directions, okay, because this is important. So solve the triangle. What does that mean for us? Find anything missing. By the way, there's usually, on a triangle, you're usually given 3 things and you have to find 3 things. That's typically what's gonna happen on a triangle. Let the measure angle C be 90 degrees. Okay, so this is a right triangle and we're naming the right angle C. If the angle is given in DMS, then the angle answers should be in DMS. We kind of just went through that. Dylan wanted to give me a decimal degree and I wouldn't let him because on the last question, my angle was given to me as degrees in minutes, okay? If the angle is given in decimal degrees, angle answers should be in decimal degrees. If you're given 2 sides and you're not given any angles at all, then you should give angle answers in degrees and minutes, okay? That's not a blanket rule for the whole semester, that's the set of directions for this section, okay? So that's just how this particular section is set up. All right, so no picture this time. Wait, how many things did I tell you were normally given? Did I give you 3? Yeah, what's the third thing that I gave you? Yeah, angle C is 90 degrees. Okay, so I did give you 3 things. All right, and so sometimes I like to set up a nice little chart. This is not so much handy in this section, but when I get into chapter 11, this is going to be really, really useful. So I'll just go ahead and show it to you now. I like to make a chart of my 3 angles. And right across from that, I like to make a list of my 3 sides where the guys with the same name, the opposites, are right across from each other. And again, it's not so much necessary in this section 9.4, but it's really useful in chapter 11, so it's good to get used to it. We know that angle B is 46 degrees. Angle C is 90 degrees. Side C is 29.7 meters. One of the reasons that I like this is that, is somebody printing? Or is somebody just gonna come in? It's a quiz, sections 3.1 through 3.4. This is so not your class. Alrighty then. Well, somebody's gonna be wondering where their quiz is. Okay, and when I like this chart because it's really easy to see what's missing. Okay, and it's easy to see whether or not we have found what's missing. There's a couple other things I like about it too, but I'll talk about those in a minute. What's the easiest thing to find first? Angle A? Okay. So go ahead, find angle A. What's angle A? Say it again. 44 degrees. Is that what you said? All right. So then what would be a good, what do you want to find first? Do you want to find side A or do you want to find side B? Eeny, meeny, miny, mo. Let's do A because it comes first alphabetically. Okay. So what would be a good way to find side A? And by the way, if you need to draw the triangle, that's fine too. That's fine. I'm visual, so I like having a triangle in front of me. It's not absolutely necessary, but it is nice to see it. So if this is my A, then this is also side A. So we've got 44, 46. So what would be good to try? Selena? Did I scare you? What should I try? Mm-hmm. Okay, if you use, which angle? Tangent of? Okay, is tangent a good one to use, guys? Myona, why isn't it a good one to use? You don't have B, you also don't have A, right? So tangent, with it being opposite over adjacent, would either be B over A or A over B, and that's 2 unknowns, so that's gonna be hard. I only want 1 unknown, okay? So Selena, can you think of something different? Not tangent, but maybe, okay. So what would you like to, do you wanna do the sine of A or do you wanna do the sine of B? Sine of B, all right. If you do the sine of B, Selena, what is sine of B going to be? Yeah, good. B over 29.7. Very good. Does that make sense? Okay. And I think it's good to use angle B because of the fact that that was given to us. All right. So that's going to be the sine of 46 equals B over 29.7. How can I solve that? What would be the easy way to solve that? Yeah, multiply the 29.7. So we're just going to enter into our calculators 29.7 sine 46 is equal to side B. And Selena, I'm going to let you finish this one up. When you enter that into your calculator, and now that I'm up here, you're going to have to scream at me. Tell me what you get. I heard the 21. What was the rest of it? How many places should you be going? Good. Good. Yeah. So we 21.36. I just lost it. 36.44. Okay. What would be a good way then to find side A? Cecilia, what do you think? A good way to find side A? Say it again. Cosine of B. Okay, so set it up for me, Cecilia. It would be cosine of B, and I'm going to go ahead and write 46 in there, is equal to what? Good. A over 29.7. Adjacent over hypotenuse. Adjacent over hypotenuse. So the math is the same. Just go ahead and multiply on both sides by that 29.7. So you got 29.7 times the cosine of 46. Cecilia, can you do that one for us? You're gonna have to speak really loud.
1.6313.
Okay, 20.63. Check your rounding on that. Yeah. All right. So I'm gonna put that into my table here, 20.6314. And then it's easy to see that I have taken care of everything in the table. Again, I don't use the table so much for this section, but it's nice to let you see what it looks like. All right. For this one, you can draw a table if you want to, or you can just go ahead and draw the triangle. So we've got 958 here and 489 here. Okay, so what's missing now? This one's a little different. Okay, both angles are missing. And? Yeah, which side? Side C, the hypotenuse. Okay, so of everything that you can do, what would you like to find first? The side. How are you going to find side C? Pythagorean theorem. Pythagorean theorem. So that's going to be c squared is equal to 958 squared plus 489 squared. Honestly, in my calculator, I would type in the square root of 958 squared plus 489 squared. I would just type it in all at one time, personally. What'd you get for that, Marina?
1,075.5859.
That's what I got as well.
What do you notice about the hypotenuse always? Can you say it again, Sam?
Yeah, it's always going to be the longest side. What angle is the hypotenuse always opposite? The right angle. And what's the right angle compared to all the angles? Isn't it also the largest? Kind of interesting that the largest side is always opposite the largest angle. And you know what? The medium is always opposite the medium, and the small is always opposite the small. Think with me about, have I showed you the hand angles? Have I done that with you? Okay. So imagine that your hands, the heel of your hands cause an angle. Okay? And imagine, because you don't have three hands, you can't do this. Imagine that the third side of a triangle connects the tips of your fingers. The third side connects the tips of your fingers. Okay, so you just have to use your imagination on that. Now, right now, that third side, that's kind of a small side, right? Look at this angle. As the third side gets longer and longer and longer and longer and longer, what's happening to the angle down at the heel of my hands, the angle opposite? It's getting larger and larger and larger, right? And that's always going to be true in a triangle. The small angle will always be opposite the small side. The medium opposite the medium, the large opposite the large. One of the things that I really like about giving a chart is that the chart, it's obvious. Take a look. The angle C, that's the large, it's opposite the large. The medium is B, it's opposite the medium. And the little is A, it's opposite A. Okay, and so that's why I like the chart. Again, it's not as useful in chapter 9, but it's going to be really useful in chapter 11. But this is one of the things I really like. I can look at this chart and say, the triangle at least makes sense. It might not be right, but at least it makes sense. Okay, because I can guarantee you if a triangle doesn't make sense, it's not right. It's not correct. Okay, I promise. All right, so then with that said, I wanted to point out the fact that side C is always, the hypotenuse is always going to be the longest side. All right, now we have to find angle A, we have to find angle B. Which one do you want to find first? Anybody know? A, because it comes first alphabetically? Okay, I'm good with that. How am I going to find angle A? What finds angles? Inverses find angles. Okay, so in my brain, I'm going to be using inverses. Okay. Now, before I start using inverses, though, I have to come up with a trig statement. So if you're going to focus on A, what would you like to use? Tangent. And why would you use tangent? Yeah, my givens are the opposite and the adjacent. Okay, so we'll have tangent of angle A is equal to the opposite 958 divided by the adjacent 489. And since inverses find angles, if I want to find angle A, then I need to type in the tangent inverse of 958 over 489. All right, Bethany, what'd you get for that one? What's that? Are you typing it into your computer? Oh. No, do you have a calculator? You just forgot it today? You're a nice sister. How kind of you. Desmos, is that what you're trying to use? Try using Desmos. Desmos.com, the calculator. And I don't care if you use that during class. That doesn't bother me. Let's see, who else can I pick on? Natalie. Okay, so she says 68.9585 degrees. You guys agree? You said 62, I'm sorry. 62.9585. Do you guys agree? I don't. Did you read the directions? Oh, go back and read the directions. It was supposed to be what, Jaden? Yeah. So what is it, 62 degrees? What did the directions say? It's a good question. So 62 degrees, 58 minutes. Yeah, and the directions did say, let's go back and take a look. If the given is two sides, then the angle answers should be given in degrees and minutes. Okay, so I didn't remind you of that, but following directions is very, very important. Okay, so just make sure. Can I give you a hint? Frequently when I'm working through these, okay, and I work your tests, I work all these problems here. When I work anything for any of my math classes, I work through the whole problem, and then the last thing I do is I go back and I reread the instructions to make sure I did what I was asked to do. It's the last thing I do for every question I ever work. I don't care what level I'm working on, okay? Whether it's Math 101, Math 111, or Math 140. Every single question, the last thing I do is read the directions again, okay? Because I just want to make sure I did what I was asked to do. So it's a good habit to get into. All right, I'm almost finished. I still need angle B. So how would I go about finding angle B? Say it again. Okay, so you could use tangent. What else? You could use sine. It wouldn't be as safe, but you could use it. What else? Complementary angles, right? Couldn't you get the complement of angle A? Again, it's not as safe. If you messed up on angle A, you're going to get angle B wrong. Okay, so Aaliyah's method is a little harder, but it's actually the safest method. So she could have done tangent of angle B is 489 over 958. And then if she did that, she could easily check her work by making sure that what she found for A and what she found for B are actually complements of each other. Okay, so it just depends on how confident you are in your answer and how much you want put in place to check your work. All right, so if you did, I'm just gonna, not with a highlighter, tangent of angle B, this is going to be 489 over 958. So that will be tangent inverse of 489 over 958. I'm just going to give this one to you. And that will be 27 degrees and 2 minutes. And again, even in my own notes, I use complements. Okay, so just there's multiple ways there. And I don't really, as long as you show your work. Oh, that reminds me, some of you are not showing your work like you should be showing your work on your tests. Okay, do you remember I told you no work, no points, even if it's right? So for some of you, I was nice to you. I still gave you points. Okay, shame on you. Next time, I don't know that I'm gonna be so nice. No work, no points. Got it? Okay. So yeah, number 6. An 18-foot ladder rests on a building wall. The base of the ladder forms an angle with the grounds. Find the distance that the ladder goes up the wall. All right, now, the first thing I want you to do is I want you to draw a picture that represents this problem. Draw a picture, and when you have the picture drawn, I want you to show it to somebody close by and see if their picture looks similar to yours. Put your numbers on the picture. You don't have any letters to put there, but put your numbers on there. And show it to someone close by.
Did you and James show that to each other?
All right. So I've got a building, right? We're not talking about the Leaning Tower of Pisa. We are talking about normal buildings. And normal buildings stand up straight. Okay? Normal buildings meet the ground at a right angle. Normal. Okay, so we're just gonna assume this is normal. So here's my building, and here's the ground. Okay, my dad would be appalled. My dad, the artist. Here's my ladder. Okay, so what are some numbers that I can put on my picture? 90 degrees. What else? Where does the 18 go? On the ladder, right? Because the ladder is 18 foot. By the way, it doesn't matter if the ladder slides down the wall, it's still an 18-foot ladder. Okay, that's not changing. What else can I put on there? Yeah, where do I put that? Good. So this guy here, we've got 40 degrees, 30 minutes. What am I looking for? What does it say I'm looking for? Yeah, the distance that the ladder can reach up the wall, right? Okay, so I'm gonna make this into an X because I don't know that value. Do the directions say solve the triangle? No, so I don't have to find everything missing here. The only thing I have to find is how far up is this ladder gonna reach? Can I wash that window up there, okay? So what can I use then? Look at the 3 pieces of information. What would be the best thing to use to find the information I want? Sine, how come? Good, because sine is opposite over hypotenuse. And one of those is what I want, and one of those is what I have, okay? So the sine of my angle, 40 degrees, 30 minutes, is equal to the opposite, which is x, over the hypotenuse, which is 18. Okay. And now all it is plug and chug into the calculator. So we've got 18 sine of 40 degrees, 30 minutes. Bethany, does Desmos work?
degrees in minutes.
Not with degrees and minutes. I haven't actually tried it. I just know that I have students who use it. You can borrow mine, just don't walk away with it. I'll forget that you have it. Until I get to my next class. And I'm like, I loaned it to her. How far up the wall does my ladder reach? 11.6901 feet. What's that?
Nothing.
Now, a couple things. I know that in real life, we wouldn't care about the 0.6901 feet. We would probably say something like, it almost reaches 12 feet on the wall, right? But for the sake of being consistent with Robert's rounding rules, we'll do what the rules say, okay? But I do understand that in a real world situation, I wouldn't care about that 0.6901. Any questions? All right, angle of elevation, angle of depression. Always, always, always starting from the horizontal. Really, I love to look at this as it's an angle in standard position. Think all the way back to section 9.1. What was an angle in standard position? What did it always have? Where did it always begin? On the positive x-axis. Can you take a look here how both of my angles, my angle of elevation and my angle of depression, began at the positive x-axis? And either I went up from there or I went down from there. Now in section 9.1, when I went up or when I went down, what did I call those? Positive or negative angles. But in a world situation, you don't have things like negative angles. You would have things like an angle of elevation or an angle of depression, okay? So an angle of depression is essentially the same thing as a negative angle. All right, so just so you know that. Okay, so let's look at number 7. The hard part about these is reading them. Okay, you ready? Here's the bad way to read this. The wrong way to read this. The angle of depression from a helicopter 3,000 feet directly above an Allied mortar station to an enemy supply depot is 13 degrees. How far is the depot from the mortar station? That's the wrong way to read. Okay, so let's read it the right way. The angle of depression. Let's stop right there. What does that mean? Where am I starting? I'm starting at the horizontal. And where am I going from the horizontal? I'm going down from there. Okay, so I got that in my mind. Now, an angle has to go from somewhere to somewhere. So let's look at the wording. It says I have an angle of depression from where? A helicopter. Now, where is this helicopter? It's in the air, right? Specifically, it's 3,000 feet in the air. Okay, but it's not sitting on the ground, it is up in the air. So let's go ahead and let's draw our helicopter, all right? Again, my dad would kill me, but that's okay. All right, you know what it is. You can tell. All right, maybe not. It's a helicopter. My helicopter, you just told me, is where? 3,000 feet in the air. Okay, so let's go ahead and just draw the distance to the ground. Now, I told you that an angle of depression, as well as an angle of elevation, goes from somewhere to somewhere. Okay, so where does it go from? You already answered this. From the helicopter, read further down the line. Where does this angle go to? So is it the mortar station or is it the enemy supply depot? Again, look at the wording. It's going from somewhere to somewhere. Yeah, look, take a look. It's going to an enemy supply depot. Okay. All right. So let's draw the angle. It's going from the helicopter. So from the helicopter, I need a horizontal. And we know the angles of depression go down. So my angle is going to go down. And that angle goes to an enemy supply depot. I'm just going to put SD for supply depot. What was the measure of that angle of depression? 13 degrees. Okay, now wait a second. So was the mortar station, was it just put in there for the fun of it? Go back and reread that first sentence. Where is the mortar station? Right below what? The helicopter. Yeah, it says that from a helicopter directly above the mortar station. Okay, so my mortar station then here, MS, is down here. Okay. Let's keep reading. How far is the depot from the mortar station? Do I have that drawn? I do. How far is the supply depot from the mortar station? Isn't that this distance right here? Mm-hmm. So this is what I want to know. Now, there's actually quite a few different ways of going about this. Okay? So here's what I want you to do. I want you to work with somebody and talk to each other about how you're going to go about this. Okay? I don't care. I don't want you to solve it yet. I don't want you to go that far. I just want you to talk to each other about how you would use trig to go about finding what I want. Go. So again, I don't care if it's really doing math right now. I really just want you talking about how you're going to go about solving it. What method that would be good to use. Okay. Okay. Alternate intervals. Okay. And what was your idea? Interesting. So two totally different methods. When we go about this, I'd like for you guys to use your separate methods and look through the repeat and see if that's the because this is vertical and this is horizontal, right? And the verticals and horizontals make how? How? Yeah, vertical and horizontal. Your picture is a little bit confusing, mostly because your helicopter is so long. So you might have drawn it with a way here. Don't change it, you just say that might be it.
Yeah, opposite. Okay, it's like the opposite of the helicopter, but it goes opposite of what size. But there's no.
Alright, so where are you going?
But you're starting from the helicopter. The helicopter is the only the angle you know. You can't use the 90 degrees. So the angle you know, which is I as H for helicopter, what's opposite of helicopter?
Okay, so
What size side is opposite the hard
I mean, I got what you're saying, but then adjacent would be that side.
3,000. And the, adjacent would be the side closest to it. Not including the hypotenuse.
13, right?
Did you get it?
Yeah. I mean, I got it, but like.
Well, how would adjacent? The hypotenuse can never be the adjacent side. Yeah, because it's opposite over adjacent.
Okay.
But that isn't the
And then do you end up with the same thing no matter
Well,
what?
okay, then what side is adjacent to the whole?
Let's find out. Let's find out.
That's the hypotenuse.
So what
did you guys use?
The adjacent side.
So.
Does that make sense?
I
Did you
mean,
draw the picture?
yeah. I mean, basically, because that's the only angle that we're sure of.
Yeah.
So that's the
I think
nice.
right,
Then the
can never
triangle
be
is
90, that just makes it opposite is hypotenuse. So that
And did you guys have the same idea or was it different? Same thing, I guess. What do you guys think?
So first we like do the equals using 13 on that.
Okay.
So you get 7, 13, tangent of 13.
Okay. All right, what about you girls?
We said from this you get 96, subtract 13, get 77.
Nice.
And then just adjacent.
Good, good. All right, so did you guys end up with the same thing? Even if you did 2 different things? Kind of no, so I saw several different things. So let's kind of regroup here. Saw several different things as I walked around. Here's the 2 main ideas that I ran into from you guys. So some of you told me that all I need to do is find this angle, and I know that these 2 angles are complements of each other. They have to add up to 90 degrees because you're looking at a horizontal and a vertical, and horizontals and verticals always meet at a right angle, okay? And so then those of you who did that, you found that this angle was 77 degrees, okay? Totally correct. The other thing that I saw several of you do is using the concept from geometry of alternate interior angles, where when I have 2 lines that are parallel and a transversal, I know that this angle and this angle must be congruent, so that then I know that this guy is 13 degrees, okay? So I saw some of you doing that as well. Both of those ideas are correct. Now, from here, though, we're going to proceed the same way, and I would personally use tangent, okay? So if you decide to use tangent of the 13-degree angle, you guys are going to be working with 3,000 over x. And if you chose to use the 77 angle, you would be saying that the tangent of 77 is x over 3,000, okay? Either way, no matter what the work is, this is number 7, you should be getting an x value here of 12,994.4276 feet. Once again, if we were working real world, if that helicopter is out to bomb the supply depot, I'm guessing the 0.4276 feet part doesn't really matter as long as the bomb gets close, right? But again, just so that we can stay consistent with Robert's rounding rules, we'll leave it like that. Any questions on that? Okay. Now, for the next 2, what I'm going to do is I'm going to, I thought these were in a video. Were they not? Okay. I'm going to, because I only have 8 minutes left. So for the next 2, what I'm going to do is I'm going to draw the picture for both. I'm not going to go through the solving. The picture's the hardest part to get. The picture's the hardest part. Okay. All right. So we're looking at number 8. You have 2 planes that are leaving the same airport. Okay. So think of the fact you're in an airport, although these days that's harder to do. And you've got 2 planes that are leaving this airport. Maybe we're at GSP. Plane A travels on a bearing of, and then there's this weird code. Okay. Here's the bottom line. Look at the letters. Do you see how the letters say northeast? That's really what you need to hang on to. okay? So first plane is traveling northeast. I'll deal with the angle in a minute. Then you have plane B is traveling which direction? Southeast, okay? Now, let's just stop right there. Let's, I'm gonna have plane A, I'm gonna call A, plane B, I'm gonna call B, and the airport that they both left from, I'm gonna call it C, okay? So here's my airport C. Which direction did plane A go? Northeast. Now, here's the easiest way to do that. The first thing that you want to do is just establish your north line. That's north, that's straight north. Okay? Now, where is east of that? Yeah, it's going to be a little bit to the right. Okay? So east of that might look something kind of like this. Okay, so that's east of the north that I established. Now, how far northeast? Now's where I want to pay attention to the number. It was 31 degrees, 20 minutes. Now let's use that same concept to figure out where plane B is. Okay, so which direction did plane B go? Southeast. So the first thing you want to do is you want to think of where south is. Straight south is like this, right? Where is east of that? Again, to the right. Okay, so maybe plane B took its trip kind of like this. And how far southeast did it go? At what angle? 58 degrees, 40 minutes. Does that make sense so far? Okay. Now, let's keep reading. Both planes left at 1 o'clock. Plane A traveled 200 miles an hour until 3 o'clock. Okay. How long was plane A in the air? 2 hours from 1 o'clock to 3 o'clock. How fast was it going? 200 miles an hour. So if it went 200 miles an hour for 2 hours, how far did it go? 400 miles. Okay, so plane A went 400 miles. Let's keep reading. Plane B was faster. It traveled 300 miles an hour until 4:30. So how long was plane B in the air? 3.5 hours, going at 300 miles an hour. You might need your calculators for that, and that's okay. How far did plane B travel? What you got? Yeah, 1050 miles. Okay, let's keep reading. Find the distance between the two airports at which the planes stopped. So I want to find side C, basically. How would I go about doing that? Before I ever start using trig, how would I go about doing that? Oh yeah, how do you know? Wait. Well, okay, but why are you telling me to never mind? I'm curious. What stopped you? I can only use a squared plus b squared equals c squared when I'm absolutely certain it's a right triangle. And I don't see any right angles. I don't see a 90 degrees. So I cannot rely on that unless I know it's a right triangle. Okay? So option number 2, it's a good option if I know it's a right triangle. What should I do?
the north line is 180 degrees, so the angle between the two airplanes angle is 90 degrees.
But how do you know it's 90? Ah, okay, so here's the deal. Take a look. This whole entire line, isn't that a 180 degree line? And haven't I already used up 31 degrees something? And haven't I already used up 58 something? So then what's left over? Yeah, the angle that I want, the inside angle at C is what's left over. And you do find out that that is a 90 degree angle. So Marino, once I know it's a right angle, what can I do? Yeah, then you can use the Pythagorean theorem. Shoot fire. I didn't have time to talk about the ship. You'll have to remind me that I didn't do this one, okay? Do me a favor though, before, what's today, Wednesday? Monday, have that one worked out. So we've gotten the picture done, have it worked out, find the distance between the two airports, okay? But you'll have to remind me because I'll forget that I didn't work number 9, okay? I'll forget that, so you'll have to remind me, okay? All right, have a good weekend, folks.